Good morning, boys and girls, and thank you for tuning in for another lesson with Mr. Fieck. Today we're going to continue talking about division strategies, but specifically looking at how to interpret remainders in different types of problems. So the learning target or main idea for the lesson is that you can use various multiplication or division strategies, and specifically focusing again on interpreting the remainders for today's lesson. So the first problem, it says each of the division problems below include a remainder. Solve each and show your work. Figure out the best way to treat the remainder for each as a whole number, fraction, or decimal. So we've talked this year a lot about there are three things you can do to interpret a remainder. One, you can just throw it away and drop it off completely of your answer. Two, you can add one more to your answer. Or three, you can break up your remainder into fractional or decimal answers. Okay, so we're going to look at different types of problems and how to interpret the remainder for each of those problems. So problem A says Rachel earned $46 for walking dogs Monday through Friday last week. If she earned the same amount every day, how much did she earn per day? So first, what is the big question asking? Well, how much did she earn per day? Okay, then do we know the total or are we trying to find the total? In this case, we know the total. She earned a total of $46. Okay, so 46 now. One thing we need to know or have background knowledge of it is Monday through Friday. How many days is that? Well, Monday, Tuesday, Wednesday, Thursday, Friday. That's 5 days. So we're going to take 46, divide by 5, and that equals our variable n. Okay, so we're solving for n. So now I need to figure out, okay, I can set up my ratio table or figure out, but again, this goes back to basic math facts. How many fives? I mean, again, you could write it as a fraction, 46 fifths, and then you could do a division because a fraction is another way of showing a division problem. How many fives go into 46 without going over? Well, let's see, 5 times 10 is 50, so 9, and the exact answer, 9 times 5 is 45, so I would have 9 remainder 1. So now that I have my answer, I need to understand and comprehend what is my answer telling me. And in this case, what is this 9 telling me? Well, that 9 is telling me, well, how much did she earn per day? So she earned $9 per day. But what do we have 1 left of? Well, we have $1 left. So now I go back to what am I going to do with my remainder? Am I just going to throw a good dollar away? Well, nobody wants to throw money away. So you're not just going to throw it to the side. Can I magically make more money appear? Well, I wish I could, but I can't just magically make more money appear. But can I break a whole dollar into fraction or decimal parts? Yeah. And that's what cents are in money. So now I have to figure out what is $1 divided by 5, or what is 100 cents divided. So now I could, if I have $1, that's 100 cents. I could figure, hey, how many, if I have 1 and 5, and I need to take that to 100 cents, okay, how much would that be? Well, if I double it, that would be 10. That would be 50 if I double that, or times 10 and times 10. Oh, 50 is half of 100. So guess what? If I double 10 again, that's going to get 20. And if I double 50, that's going to get me 100. So how many cents would she have per day? That would be 20 cents. So now how much would she earn per day? That would be $9.20. And then again, one thing you could do just to double check and make sure, take $9.20 or 920 cents, times it by 5, and you should end up with 46 or 460 cents. Okay. All right. Now let's go look at another problem. So there's an example of a problem where we had to break up our remainder as fraction and decimal answer. Bryson bought 27 balloons to share with his 3 friends. How many balloons does each of the 4 friends get? Okay. So they want to know how many total balloons everyone's going to get. Do we know the total? Yep. We have 27 balloons. And how many equal groups are we trying to split that into? Well, it says Bryson bought 27 to share with 3 friends. But Bryson also wants a balloon, so it's 4 children. So how many did all 4 of them get? Okay, so 27 divided by 4 equals n. So now, knowing my basic math facts, I know Well, 6 times 4 is 24. 7 times 4 is 28. Well, 28 is more than that. So 4 can go, there can be 6 groups of 4 that go into 27, and I would have 6, and I would have 3 remaining. Now, I need to understand what this is telling me. What is my 6 telling me? My 6 is telling me that they will each get 6 balloons. Because how many balloons? They will each get 6. What do I have 3 remaining of? Well, I have 3 balloons remaining. Now, can I magically make more balloons appear? Nope. I'm not a magician. Can't do it. Can I cut balloons into fractional parts and they would still be good? No, because if I cut a balloon into fractional parts, the balloon's not going to be good and it's not going to hold any air. So in this case, I'm just going to drop this off. And how many balloons would each friend get? Each friend would just get 6 balloons because they want to share them equally. Okay? So there's an example where I just kind of put the remainder off and throw it away because it's not fair if other people get 7 balloons and another person gets left with only 6. Okay? But here complaining nonstop that it's not fair. So we're just going to give everybody 6 balloons. Okay? And then let's look at one more problem to wrap it up today. Rope comes in 16-foot lengths at the hardware store. Jorge bought 1 rope and then cut it into 3 equal size pieces. How long was each of the 3 pieces? So we know the total length is 16. Okay, and how many equal parts is he dividing it into? He broke it up into 3 equal parts. So we're trying to solve 16 divided by 3 equals what? So basic facts again. How many times can 3 go into 16 without going over it? Well, that would be 5. Okay. And then I have, well, 5 times 3 is 15. I would have 1 remaining. Okay. So my exact answer would be 5 remainder 1. Okay. So now, how long was each of the 3? So can I magically make more rope appear? Nope, can't do it. Am I just going to throw good rope off to the side and throw it away? No, that would be kind of wasteful, right? But I can break a rope into fractional parts or decimal pieces. And in this case, if you have 5 remainder 1, you can take your divisor and put it over your remainder, and your fraction would be 5 and 1/3. So how long was each piece? Each piece was 5 and 1/3 feet long. So these are just some examples of different types of problems where you have to interpret the remainder and what you're going to do with it. Remember, 3 options. You can throw it away, you can add 1 more to your answer, or you can break it up into a fraction or decimal part. So I hope this is a good review, and I hope it helps remind you of how to interpret remainders. Thank you for watching the video, and go make it a